Today's video is going to show you how to use a hydrometer. I'm not expecting your average student at home to have one of these, but it is standard practice in soil science, so I wanted to do a demonstration so you could see how this works. First, we need to weigh out our soil sample. So I weighed out 50 grams approximately of soil, and then I put it through a sieve. So 2 millimeter sieve. All that's left now are stones that are not, they're too big to be sand. Sand particles, as you might recall from lecture, only go up to 2 millimeters. I then put that in a mortar and pestle and I ground up, not hard, but enough to break up any pieces that were chunked together and cemented and not actually solid pieces. Then we're going to take this part and put it into 100 milliliters of sodium hexametaphosphate, which helps the colloids disperse into the water column. The easiest way to do this is with a funnel. I like making a homemade paper one. And I want to get all the small fine particles in there as well. This soil is very dry. Depending on your lab at this point, you might have a blender of some kind that you would put this sample in to get ground up even more. We don't have one of those in our lab. So I have ground it in the mortar and pestle and I'm mixing it with dispersing fluid, and that is all I'm going to do. I'm going to then put it in this water column, and I want to get all of it in, up to a 1 liter mark. So I measured out some water, but then I saved some behind because I knew it was going to take several rinses to get all of this out. Trying to get as much of my sample in there as possible. I don't know if you guys can see, there's already some organics floating on top. And the column is pretty cloudy, which means there were a lot of clay and or silt particles that were visible. So I've already marked on this cylinder where 1,000 milliliters are. So that's with the soil sample and the dispersing fluid added, 1 liter in this column. So I'm going to put that up there so you guys can see it a little bit closer. I also here have a blank, which is just water that's the same temperature as this water, and it has the same amount of dispersing fluid, it just is missing the soil. So this is a hydrometer, and it is a way of measuring how many colloids are in suspension. So I want to know, I want to calibrate my hydrometer. So I'm going to put it in here, and it will bounce a little bit at first. And I can see that even though there is no soil in this cylinder, that my hydrometer is not at 0. It is between 7 and 8. So this hydrometer is between 7 and 8 without any colloids in it. So I have to remember that in terms of adjusting for when I put it in my actual sample. I'm then going to mix this sample because in this time that I've been talking with you, all the sand has gone to the bottom and some of the silt has started to settle. So I want to get as true a measurement as I possibly can. Just grabbing a timer. Forgot that I need a timer because the first measurement you take as soon as you put the hydrometer in, but the second measurement you take 40 seconds after. Okay, so I'm going to get my hydrometer ready. And I'm holding it, I'm very carefully holding it so as not to get any grease on the measurement itself. You don't want any grease stopping the measurement. Take this out, put this in, and it's bouncing 20, 25 maybe. And it's slowly going down because as the sand settles, there's less colloids in suspension. So with the sand in there, it was pretty high. It sort of settled out at about 25, but now it's at 15, 16. And I'm going to wait 40 seconds. 40 seconds is the amount of time it takes. That's 40 seconds. And we're now at 14. So that is our clay. And then I'll leave it here, or our silt, and I'll leave it here and figure out what the clay is. The clay takes 6 hours and 52 minutes. So here's our hydrometer close up. The measurements are in grams of soil colloids per liter, which is why it's important to have this be a full liter. So when it said 14, that means there's 14 grams of colloids in this liter. However, we started at a different measurement, so we need to take that away. If our hydrometer was measuring 8 in here, and then we are at 14 when we did our 40-second measurement here, that's 14 grams of silt and clay colloids in suspension still, except we were at 8 over here, so it's actually only 6 grams of silt and clay particles. In 6 hours and 52 minutes, we will check this again, and that will tell us how many clay particles there are. So we'll know silt plus clay, and we'll know clay, and we'll be able to subtract that to find out exactly how much silt. And then because I weighed how many grams of soil there was to start with, that will let me know how much sand. The majority of this sample is sand. As you can see, the hydrometers go all the way to 60 grams. So if there were more, like if I put a 50-gram sample in there and most of it was clay, it would be sticking out of the suspension quite a bit. But it's a pretty cool little tool.